expresses a single logarithm with coefficient 1. 3 times log base 5 of x plus log base 5 of y minus 2 log base 5 of z. Now the first thing we should do is simplify each of these terms, and so notice that for the x term and the y term we have coefficients outside, and let's recall that when you have a coefficient outside of the log, well, the exponent rule says that you can move that coefficient up to become the exponent of whatever variable it is you're talking about. So for the first term, this becomes log base 5 of x cubed. The middle term stays the same, and the last term becomes log base 5 of z squared. Then what I want to do is focus on these two first guys here, and I want you to remember the product rule for logs, which says that if you have a log base b of a product, then what you can do is split up log base b of x, split up the logs, right? So notice that these two guys look the same, so we can actually replace it and turn these into a product with just one log. So doing the backwards substitution with the identity, this is going to become log base 5 of the product x cubed times y, and then we still have that log base 5 of z squared. Then finally, looking at these two guys, we recall the quotient rule, which says if you have log base b of some quotient, what you can do is split up the logs with a minus sign. So this will become log base b of x minus log base b of y, which looks very similar to what we have up here. So now doing that backward substitution, that means that this expression is going to become log base 5 of the quotient of the first divided by the second. So x cubed y over z squared. So we've written our logarithmic expression with just one log that has a coefficient of 1, and so we're done.